Okay, so welcome to the lesson on different types of linear system solutions. And so far what we've done is solved linear systems of equations using the elimination method and then using the TI-Nspire calculator. What we're going to do today is not solve linear systems specifically, but we are going to look at the different kinds of solutions that we can get. And so essentially what we've done is I'm going to drop down to the second one here. These are the types of linear systems we have solved so far. And so in all of them, what's happened is we've had two lines. If you were to represent them graphically, we've had two lines and they've had a single point of intersection, and the coordinates of that point of intersection, which in this case would be -2, 0, would be the solution of the system. So one x value and one y value. And what we're going to do now is look at systems of equations graphically, so the graphs of systems of equations, and see what the different types of options are. So this is the most common, where you have two lines. They clearly have a different slope, so slopes are not the same, and they have got different y-intercepts, but the most important thing is the slopes are not the same, and they intersect each other at one point. There are in fact, as you note here, and this is not hugely important, but the notation that the textbook uses, or the naming, is that these systems are consistent, which means they do produce a solution, and they are independent, which means they produce one solution, as in one x value and one y value, one point of intersection. There is a second possibility where the two lines that you graph, if you were solving them graphically, actually have the same slope but different y-intercepts. As you can see here, the red line has a y-intercept of -5, the blue line has a y-intercept of 1, and what this results in is lines that are parallel to each other. Because the lines are parallel, they will never intersect, and because they never intersect, we will have no solution, or we will have a system which we describe as inconsistent. So inconsistent essentially means there is no solution. Okay? And the third possibility, so we've had three possibilities. The first one is a consistent system, which means there is a solution, and it is independent, which means there's a single solution. The second option, which I just explained, inconsistent, so we have parallel lines and there's no point of intersection or solution. And the third possibility is that they are consistent, so we do have a solution, but we describe them as dependent because there are an infinite number of solutions. In other words, slopes are the same and y-intercepts are the same. What that really means, as you can see from the graph, is that the two lines lie exactly on top of each other, and they essentially have the same equation. And that you're probably thinking that should be very obvious to spot. It can be, but remember, systems of equations can be given in a form that needs to be rearranged, and so sometimes this won't be that obvious. Okay, so that's essentially the content, and what we're going to do now is, if you have a look at these three, these are all graphical representations, graphs, and if you were solving a system on your TI-Nspire, this is what you would see. If you would graph it, you would probably notice that the slopes are parallel, they would have no intersection. This would be the regular intersection, the second one, and the third one would be where you type in the same equation. You can recognize what kinds of answers you're going to get simply using algebra. Okay, and so I'm going to show you that right now, and in order to be able to recognize them using algebra, you need to understand y equals mx plus b. Remember, the m represents slope, and the b represents the y-intercept. Okay, so what we're going to do is we're going to go ahead, and we've got three examples here, and you'll notice the instruction is without solving. So all we're going to do is, as the note says, rewrite the equations, each of the two, in slope-intercept form, and that should allow us to determine how many solutions we're expecting. One, none, or infinite. Okay? Alright, so let's begin. So this one has already been done for us. Y equals x plus 2, so we have a slope of 1 and we have a y-intercept of 2. And what we need to do is rearrange the second equation over here. So the first thing I'm going to do is I'm going to subtract 2x from both sides. So that's going to give me minus 2y is equal to minus 2x minus 4. And then I'm going to divide all terms in the equation by minus 2 so that I can get y by itself. Minus and a minus is a plus, so we have 1x, minus and a minus is a plus again, plus 2, and hopefully what you realize at this point is we have our two equations which are identical, and so this is going to be an example of a system which has an infinite number of solutions, and this is a system which we, as you can see from above, this system is described as a consistent dependent system. Okay? Alright, so if we move to our second example, and once again the procedure will be the same. First we're going to get this into the y equals mx plus b form. Okay, so this first equation I'm going to subtract 5x from both sides and rewrite my equation over here. Y is equal to minus 5x plus 6. In the second equation, I will add 5x to both sides to begin with. And so I'll have minus y is equal to 5x plus 3. And then I'm going to divide through by minus 1 because we must have it in the form y equals, not minus y equals. Those are not the same thing. And so y is equal to minus 5x minus 3. Now we can analyze our two equations. Those are our two equations which have been rewritten in y equals mx plus b form. And what you can observe is that we have got the same slopes, but the y-intercepts are not the same. So if you recall from the previous example, what this is going to mean is that if the slopes are the same, the lines are going to be parallel, but if they have different y-intercepts, they're going to be parallel. So if I were to graph this, and I'll just draw a very rough sketch, if I were to graph this, what we're going to have is one of the lines heading down that way, and the second one heading down this way with its y-intercept of minus 3, and those two lines are going to be parallel to each other. And so this is going to be an example of a no solution system. Empty sets, another way to say it, or inconsistent is the terminology the textbook uses. Okay, third time, and we'll just do the third example to show you the third possibility. So the procedure starts the same. I'll subtract 5x from both sides because I want to get these in y equals mx plus b form. And in this case I'm going to have y is equal to minus 5x plus 2. The second equation, what I'm going to do this time is something a little different. I'll plus y to both sides, and I'm going to subtract 4 to both sides, and the result will end up exactly the same. So those 4's are going to cancel, and I'm going to end up with y on the right hand side. It doesn't matter if I write it on the left. The y's will cancel, and I'll end up with x minus 4. And at this stage, what's important to note is that if you look at the two slopes, and the slope here is of course 1, that slopes are not the same, and immediately if the slopes are not the same, that tells us that there is going to be one solution. And remember, when I say one solution, what I mean is one x value and one y value. So that solution is an ordered pair or a point of intersection, and so that's an x value and a y value. And if you wanted to actually find the answer of that, of course, if we were solving by graphing, we would go in and use the TI Nspire, graph each of those and calculate the point of intersection. Okay, and that concludes the video on types of solutions to linear systems, and you should now turn your attention to the assignment.